Dear students, today we'll see the sixth part of Industrial Automation subject MCQs, in which we are going to see MCQs on electronic control of motors and PLC. So let's start with the questions. Question number 101. The speed of a DC motor can be varied by. Okay, now if you remember the DC motor, so DC motor will be having two windings, and the windings will be shown as armature and field windings. So here you can see you have armature, which can be denoted like this, and you can have field winding. Okay, so armature winding is there and field winding is there. Armature has to be given a voltage and field also has to be given where the field current will flow. Okay, so here, so this armature winding will have a supply, field winding will have a supply. Okay, and a resistance in series with armature also can be used to vary the supply. So in this question, the speed of a DC motor can be varied by varying. You can vary the field current and you can vary the speed. You can vary the applied voltage and you can vary the speed. You can have a resistance in series with the armature, and with that variation of resistance also you can vary the speed of the DC motor. So here the answer will be any of the above. Means all of the above is the answer. So option D will be the right answer here. You can vary the speed of a DC motor by field current, applied voltage, and also resistance in series with armature. So here you can see option D, that any of the above mentioned will be used for varying the speed of a DC motor. It can be varied by varying field current, it can be varied by varying applied voltage, it can be varied by varying the resistance in series with armature. Then we'll go to question number 102. If a DC motor is connected across the AC supply, it will. Option A is run at normal speed. Option B is not run. Option C is run at lower speed. Option D is burn due to heat produced in the field winding by eddy current. Now, if a DC motor, which is expecting a DC supply, if it is connected to a AC supply, so AC supply will be an alternating current. It is an alternating quantity due to which heat will be produced in the winding. So option D, that the motor will burn due to heat produced in the field winding by eddy currents, will be the right answer. So here you can see, if a DC motor is connected across the AC supply, it will burn due to heat produced in the field winding by eddy current. Then we'll go to see question number 103. If the terminals of armature of DC motors are interchanged, this action will offer following kind of braking. Option A is regenerative, option B is plugging, option C is dynamic braking, and option D is none of the above. So here, when we studied speed control of DC motor, so we had a motor here. So we had a motor here. Say you are having a motor here. This is motor, this is the armature winding, and you can show a field winding here. Okay, now this will be connected by a converter on one side, which will be called as P converter, and it will be connected by a converter on the other side, which will be called as N converter. N converter. Okay. Now here P converter is going to convert AC to DC, and N converter also is going to convert AC to DC. Okay. Now if you apply P converter, the motor will rotate in one direction. Say if it is rotating clockwise like this. If you apply N converter, if you make N converter to work, then the motor will rotate in anti-clockwise direction. Now here, the question is asked, if the terminals of armature of DC motor are interchanged, this action will offer which kind of braking? Okay. Now here the offered braking will be called as plugging. That is the second option. Now here, in plugging, what will happen is, we have to assume that the P converter is originally on and the motor is running in clockwise direction. If the P converter is made off and then N converter is made on, okay, the direction of the armature current is reversed and the motor tries to rotate in opposite direction. The inertia would oppose the torque developed in the anti-clockwise direction. When the two opposing torques, torque means the bending force, the bending moment. When the two opposing torque becomes equal, the motor stops, provided the N converter also is made of. This process of stopping the motor is called as plugging. So here you have to remember the P converter N converter operation. So by P converter making on P converter, you are going to rotate the motor in one direction. If you make the N converter on and P converter off, you can make the motor to run in the other direction. So initially you on P, then you off P, you on N, then you off N. So both the torques, one is clockwise direction and one is anti-clockwise direction. Both the torques, when they become equal to each other, obviously the motor stops. And this type of braking is called as plugging. So here you can see option B, plugging is the right answer. Then we'll go to question number 104. The armature voltage control of DC motor provides what? Option A is constant voltage drive, constant current drive, constant torque drive, or none of them. So here, when we studied armature voltage control of DC motor, we have seen that whenever we have this armature voltage control concept, it is a constant torque drive. That is the bending force, the bending moment is constant torque drive. Okay, so option C will be the right answer here. It is constant torque drive. So here you can see the armature voltage control of DC motor provides constant torque drive. Then we'll go to question number 105. When the armature of a DC motor rotates, EMF induced is called as what? So options are self-induced EMF, mutually induced EMF, back EMF, and none of the above. So here the answer is back EMF. Back EMF is an EMF that is produced by a turning armature. Okay, so whenever armature is going to rotate, it is going to turn, it is going to produce an EMF. An EMF will be induced in it, which will be called as back EMF. So back EMF is an EMF that is produced by turning armature, which always opposes the applied voltage. So whatever voltage you are applying to the armature, that voltage will be opposed by this induced EMF in the armature. That is the back EMF. Okay, back EMF is also called as counter EMF. Clear? So it is an EMF induced in the winding because of the voltage applied, and that EMF is going to oppose the applied voltage, and that is called as back EMF. It is also called as counter EMF. So here option C, back EMF, will be the correct answer. When the armature of a DC motor rotates, EMF induces back EMF, because back EMF is an EMF that is produced by turning armature, which always opposes the applied voltage. Then we'll go to question number 106. Regenerative method of braking is based on that. Option A is back EMF is less than the applied voltage. Back EMF is equal to the applied voltage. Back EMF of rotor is more than the applied voltage. None of the above. So obviously, when the applied voltage becomes equal to the induced voltage, induced EMF, that is when back EMF is equal to the applied voltage, because it is always opposing. When the back EMF is equal to the applied voltage, there is braking. That is regenerative method of braking. So here option B will be the right answer. Back EMF is equal to the applied voltage. So regenerative method of braking is based on back EMF is equal to the applied voltage. Then we will go to question number 107. If you have a light dimmer circuit using an SCR. So if you remember the light dimmer circuit, it is a circuit which will dim the light. The intensity of light will be reduced. Okay. So in testing the circuit, you will find that the gate current given to the SCR. So SCR is a controlling element here. The gate current given to the SCR is 0 milliampere and the light is still on. You conclude that the trouble might be one of the following. So gate current is 0, SCR is not going to do any work, and the light is on. That means the circuit is normal. You have not done any dimming action. You have not done any dimming action. There is no switching of the control element. There is no gate current flowing. The light is still on. So out of these four options, option A is the SCR is open, option B is the switch is faulty, option C is the gate circuit is shorted, option D is this is normal, nothing is wrong. So option D is the right answer here. Because when the gate current is zero, you have not triggered the SCR. SCR is not going to work and control the dimming of light. So light is not dim, it is on. So it is a normal condition. Nothing is wrong with the circuit. So it is option D, which is the right answer. So here you can see you have option D. This is normal. Nothing is wrong with it. Then we'll go to question number 108. Which of these following sensor is a useful part of a burglar alarm circuit, burglar alarm system for commercial buildings? So whenever we have burglar alarm, we have a micro switch which has to be operated, which has to be activated, and then the control element will be activated, and then you will get some noise. Okay, so here options are movement detector, door sensor, window sensor. So even if there is any movement of any particle, the micro switch will be operated. Even if the doors are moved, open and closed, the micro switch will be operated. Even when the windows are open and closed, the micro switch will be operated. So all of the above mentioned are the part of a burglar system because all of this will make the micro switch operate and the control element will operate and the burglar alarm will be activated. So all the above three mentioned will be part of your burglar alarm system. So here you can see all the above mentioned is the right answer. Then we'll go to question number 109. The acronym PLC stands for. So what is the full form of PLC? PLC we have studied and the full form of PLC is Programmable Logic Control. So it is Programmable Logic Controller. That is option B will be the right answer. So here you can see PLC means Programmable Logic Controller. Then we'll go to question number 110. The part that monitors the inputs and makes decisions in a PLC is called as what? Now, in PLC, we know that PLC we have a main CPU, and to CPU you are going to give inputs, okay, and CPU is going to give you the output. So inputs can come from sensors, and outputs can go to your activators, motors. So you can have actuators, you can have like motors, okay, solenoid, all those can be your outputs. Okay. So here the part that monitors the inputs and makes decision in a PLC is the CPU. So CPU is the part which does this. So this is a true statement. So the option is true. So here you can say it is true. The part that monitors the inputs and makes decisions in a PLC is the CPU. Then we'll go to question number 111. One of the following is an input device. So if you see motor is a output device because after the command from the CPU, it is going to get on. Light is the output device. If you get a command from CPU, it is going to go on. Valve also will operate as the output device. Whereas sensor is one which is input device. It is going to sense the parameter and give the data to the CPU. So the input device is sensor. So here option D will be the right answer, sensor. So here you can see one of the following is an input device, that is sensor. Then we'll go to question number 112. Which one of the following is not a PLC manufacturer? So if you remember, PLC manufacturers. So here if you see the options, Siemens manufactures PLC, Mitsubishi manufactures PLC, Microsoft does not manufacture PLC, ABB manufactures PLC. So which one of the following is not a PLC manufacturer? The answer will be Microsoft. Microsoft is a company which is not manufacturing a PLC. So here you can see option C is the right answer. Then we'll go to question number 113. Solenoids, lamps, motors. These are output devices are connected to what? Analog output, digital output, analog input or digital input. Obviously, it is digital output. So after the CPU, whatever indications you're going to get for the output devices, those will go to either solenoids or lamps or motors and they are connected to digital output. So option B is the right answer here, digital output. Then we'll go to question number 114. What does NC stands for? So whenever we use the PLC ladder diagram, that there is a diagram which is used for programming In that, we use switches which are NC or NO. So NC will be normally closed, NO will be normally open. So here in this question, what does NC stands for? NC stands for normally close. So option B will be the right answer here, normally close. So here you can see NC stands for normally close. Then we'll go to question 115. Among following, which one is a PLC programming language? Options are assembly language, ladder logic, Java programming, or HTML. It is obviously the ladder logic. We use ladder logic as the programming language for PLC. So your option B will be the right answer. That is the ladder logic. Then we'll go to question number 116. Ladder logic programming consists primarily of what? Options are virtual relay contacts and coils. Option B, logic gate symbols with connecting lines. Option C, function blocks with connecting lines. Option D, text-based code. So out of this, option A, that is the virtual relay contacts and coils are used in the ladder diagrams, in the rungs, in the horizontal lines. So those are virtual relay contacts and coils. So your option A will be the right answer, virtual relay contacts and coils. Then we'll go to question number 117. In a PLC, the scan time refers to the amount of time in which options are the a technician enters the program. Option B is our timers and counters are indexed by. Option C is one rung, that is the horizontal line of ladder logic takes to complete. Option D is the entire program takes to execute. So in a PLC, the scan time refers to the amount of time in which the entire program it takes to execute that time. So option D will be the right answer here. The entire program takes to execute. So here you can see in a PLC, the scan time refers to the amount of time in which the entire program takes to execute. Then we'll go to question number 118. In a PLC programming, a retentive function is one that options are defaults the on state, comes last in the program, defaults the off state, it is not reset after a power cycle. So option D is the right answer. A retentive function is one that is not reset after a power cycle. So your option D is the right answer. It is not reset after a power cycle, that is a retentive function. Then we'll go to question number 119. Normally open contacts are open when options are when input is not energized, when the input is energized, when the input is higher than 20 volt, none of this. So if you take normally open contacts, so when the input is not energized, they are normally open only. But when you energize the input, they become closed. Clear? So normally open contacts are open when the input is not energized. So option A is the right answer here. When input is not energized, at that time only normal open contacts are open. Okay. Then we'll go to question number 120. Which of the following instructions enables a jump to a subroutine? So in a PLC programming, if you see, obviously the jump is given as JMP. So whenever you use JMP, it is enabling a jump to a subroutine. So JMP is the answer here. So option A, JMP is a enabling jump to a subroutine. It is an instruction which will enable a jump to a subroutine. So here option A, JMP will give the correct answer. That is the instruction which enables a jump to a subroutine. Thank you, students.